What's up, everyone? This is LeetCode 200, number of islands. So we're just given a binary grid, right? It's 2D, and we have a bunch of ones and zeros. The ones represent land, the zeros represent water, and we have to return the number of islands, okay? You can read the problem statement for yourself. I'm just going to go to an illustration, right? So basically, we have ones that represent an island, and islands are connected horizontally and vertically, right? So for example, this is a 1, but these are not different islands. They're all part of the same island, right? Because they're connected. They're adjacent to each other, right? So this, for example, this here would be only one island, right? Now, why? Because they're all connected, right? You can see. Because again, it's horizontally and vertically. Okay, so this is one island, right? This here, for example, is 3 islands, right? Does that make sense, right? Because remember, not diagonally, only horizontal and vertical. Are these connected in any way, horizontal and vertically? Well, of course not, right? There's water separating them. Same here, right? These aren't connected horizontally or vertically. There's water separating them. So these are all separate islands, okay? And so we basically need to count the number of islands, right? And so how do we do that? Programmatically, right? And there's a few solutions to this problem. There's a slightly less optimal approach and there's a more optimal approach. I'll go with the suboptimal approach first, just to kind of make sure you understand the problem, because I think the suboptimal approach, it is suboptimal, but it will help you understand the gist of the problem, even though it's slightly more complicated. But I'll still show it to you anyways, because I think it'll help you understand the problem more. And so the suboptimal approach, which is what we'll start with, the gist of it is that we're going to use a visited set, right, to basically keep track of adjacent nodes, right? So for example, we're going to iterate through this grid, right? Right? And we only care about the one nodes, right? The land. Okay, so when we go here, for example, right? This is not in our visited, so we're going to add it 1 to the island, and then we're going to pass this, the coordinates of this, off to a BFS function, okay? A breadth first search function. And in that BFS function, we're basically going to go forward directionally, right? And if we're in bounds and we encounter a 1 that is not invisited already, then let's keep expanding that recursively, right, forward directionally. And so that we can cover basically all the land nodes that also are part of this node, right? So that's basically how we count islands, okay? And for example, when we're down here, right, we do it forward directionally, right? And then from these forward directionally, right? Because again, this is recursively, right? So we would count all these, island B1. Well, when we get to this 1 here, this is not in our visited set, right? So basically, we would add 1 to islands again, and we would pass this off to the BFS function. Of course, forward directionally, there's no 1s, so we wouldn't worry, but we won't have to do too much work there, right? Then we go down here, we hit this 1. This is not in our visited, so we add 1 here, and then forward directionally, right? Now, when I say we do forward directionally, like recursively handle this problem, the reason we're not incrementing islands all at once, like when we're here and we're going forward directionally, why are we not increasing islands at this point? It's because, again, when we're here, this is the first 1 we encounter that's not invisited, and we go forward directionally from here. When we get here, though, or here, or here, and we're going forward directionally, all these are going forward directionally in the BFS function, and that's not where islands is increased. This is the island variable is increased outside of the BFS function. So that's how basically we maintain the proper count, okay? It'll make more sense in the code. It'll be very obvious, okay? So first of all, let's create our rows and our columns, okay? So we're going to say length of grid, columns is length of grid, right? We'll create our counter for islands. We're going to have to make our directions, right? We'll keep this in an array. So add 1 to the row, subtract 1 to the row. Then we have to do the same for the column. So add 1 to the column, subtract 1 to the column. Right, we're just going forward directionally. That's what this array is for. Then we have a queue, right? Because again, this is a BFS implementation. Okay, so let's say BFS, row, column. Okay. Now we'll get back to this later. First of all, let's iterate through the entire grid. Okay. So we're going to say for R in range rows, for C in range columns, right? If grid of RC is equal to 1 and that those coordinates are not in the visited set, right? This is where we add 1 to the island, right? Right? But we also need to pass this on to the BFS, okay? So we mark all the adjacent nodes also as part of the same island. And we mark it by adding those to the visited set, okay? And at the end of this program, of course, we need to return the count of the islands, so we're gonna do this. Okay. And up here is basically where the bulk of our work happens, okay? So when we pass something into the BFS function, we need to add that to our visited set, okay? So we're gonna say RC, right? Whoops. RC. We have to do this obviously also because we're going forward directionally, right? So when we go here and we're going forward directionally from here, we might hit this again. Or when we're here, we might hit this again. And if it's already in our visited set, we don't have to mark it as having been there, right? Because obviously it's already in our visited set. That's kind of the point of that also. And we append it to our queue, right? Because this is a BFS. Okay, so while there's something in the queue, right, we need to basically pop from the queue. So we're going to say row column is queue.pop left. And again, what we're popping is just a row and a coordinate, okay? So when we pop something from the queue, we want to basically take whatever we popped and basically add the direction to it, okay? So we're going to say R is equal to row plus dr, C is equal to column plus D, right? Here basically we're just setting up the coordinates for directionally depending on what direction we're going in, right? Because again, we're iterating through the array here. So for example, when we pop from a queue, right, maybe we want to add 1 to this row or subtract 1 to this row, or add 1 to this column or subtract 1 from the column, right? Because again, we're going forward directionally, so we have to do that in all 4 directions. So we're basically going up, down, left, right. And when we go up, down, left, right from a specific node we pop, we basically want to make sure that we're in bounds, which is what this is doing. Okay, we're checking that this is in bounds. We're going to say is less than columns. And we want to say is the grid of going up, down, left, right, is that in bounds and is that equal to 1? And if that is not in the visited set, then at that point, what we can do is we can append that to the queue. Okay. So what we're doing is like we're adding nodes to the queue, right? When we go left, right, up, down, right? And if it's not in the visited set, like for example, when we're here, we go down and to the right. These are not in the visited set, right? So we're gonna add those to the queue, and we're gonna put these as visited. Okay. Now when we go here, because it's in the queue, we're going forward directly from there, okay? Well, this isn't in the visited set, so we're going to put in the visited set and also in the queue. And from here, we're going to go forward directly, right? So that's kind of how we map out our island, so to speak. Okay, I hope that makes sense. So we're going to say this. We're going to say visited.add RC. Okay. And I believe that should be it. Unless I did something wrong. Invalid syntax. Line 19. Okay, here. I think it's because I tried to... Oh, sorry. Forgot my coordinates. And I'm gonna say and RC not in visited. This up here should be a deck. There you go. Right, because it has to be a double-ended queue. That's the point of popping from the left, right? And here, let's see. I'm gonna say visited is not defined. Did I create the visited? Oh, I did not create the visited set. Sorry about that. Like I said, this is slightly suboptimal, and I'll show you why. The optimal solution is way more simpler, but the reason I have to show you this is because I think this solution, even though it's a little bit more complicated, it'll show you how to do the problem and understand it. Okay, so this passes all test cases. This is fine, right? So this is a solution. Okay. I'll just run through it really quick just so we understand what's going on here. Okay, so we're setting up the rows and the columns, right? By getting the lengths. We're setting up the island variable, right? Initially at 0. We're setting up the direction array, which we use to go when we're at a specific point. We use the direction array to go up, down, left, right by taking the coordinate that we're on and adding whatever the coordinates of this are, right? Because the for loop. We set up the queue, right? Double-ended queue. We set up the visited set. Okay. So again, this is just the BFS function. This is actually where we call it. So I'm going to start down here first. So we're going to iterate through this matrix, right? Or this binary grid. And if we encounter a 1 that's not in the visited set, we have to call the BFS function, okay? And after we exit the BFS function, all those recursive calls, then we add 1 to the islands. Okay, so we go here, right? This is equal to a 1, and it's not in the visited. So we pass the coordinates of this into the BFS. So this gets added to the visited set. This gets appended to the queue, right? Well, while there's something in queue, which there is because we just added it, right? We basically pop this from the queue and we go forward directionally from this coordinate here, right? And when we go forward directionally, whatever direction we go in, up, down, left, right, if that is in bounds and that node is a 1 and it's not in the visited set, then we also append that node, right, like this, to the queue, to the visited, and we go forward directionally from there because we're in this while loop with the queue, right? That's basically how we map out every island, okay? And then, of course, we would exit that call stack once these are all set to visited. Or maybe example 2 is better to explain that because this has more than one island, right? So we append all these ones to the visited set, right? And we iterate forward directionally. So we exit that and we're down here again, right? And we keep iterating, okay? And at some point we hit this 1 here. Okay, so we have to go into the BFS again and go forward directionally, do all that stuff. And then when we exit, we add 1 to the island, right? And then we have to do the same when we reach this point, right? Because it's a separate 1 that was not in the visited set because, again, we can't reach it forward directionally from here or from anywhere up here, okay? And so we'd get a 3, actually. So that's kind of how this solution works. I think the first time you encounter this problem, it's a little bit more complicated than it seems. It's actually not that complicated. But you can do this in a simpler way, okay? And that is without using data structures. And I'll explain it, okay? So what we can do is, first of all, let's get the rows and the columns, okay? Again, because we can iterate. Okay, so we're going to say rows is the length of the grid, the columns is the length of the grid, row, okay? And we have to have the island variable that we have to return, okay? So we have to do the iterate through the grid again, okay? Just like we did the first time. So we're going to say for R in range rows, for C in range columns, right? We have BFS if grid of RC is equal to 1, right? BFS RC, pass that the coordinates, and add 1 to the island again. Okay. Pretty simple. Okay, now let's do the BFS function. How would we even do this without using a visited set or anything? Okay, that's what you may be wondering. And there's actually a really neat trick we can do, which is that when we pass it a coordinate, okay, when we pass it a coordinate from here, okay, let's check a few things, okay? Let's check that it's in bounds, okay? And this may seem weird. Why the heck would we check if it's in bounds? Obviously, it's in bounds if we're iterating through the grid, right? And I'll show you why, okay? So we're going to say if this is in bounds and the column is also in bounds and the grid is equal to 1, then what we can do is we can set the grid equal to 0, and we can just recursively, right, handle it like this. Basically go forward directionally at this point, okay? And the neat trick about this is that we're basically not using a visited set here, right? Or any complicated data structure, because we're simply just changing the value from 1 to 0, right? So that's how we are going to mark it as visited, okay? And I believe that should be it. Okay. Oops, invalid syntax. Where did I mess up? If, oh, I didn't say an if. I was a bit, I think these have to be indented. Okay, let's submit this. And just like that, it works. Okay, so what we're doing here is we're basically we're doing the same thing, right? Where we call BFS. Like, this is functionally the same as the previous solution that's less optimal. But instead of using a visited set or any of that to mark all the adjacent nodes as part of the same island, why don't we just set them to 0? Because they don't matter ultimately, right? Like, in terms of the count of the islands, they don't matter. So when we're at this 1 and we go forward directly, why don't we set these to 0? Because when we're iterating through these for loops, if we encounter a 0 here instead of a 1, does it really matter? No, it doesn't, because we're going to skip it in either case, right? Like, even in the previous solution, we would skip this 1 because it would be in the visited set already, right? Does that make sense? So by setting this to 0, we're basically doing the same thing, except instead of using a visited set, we mark it as visited by setting it to 0, right? Which is what we're doing here. Okay, so that's kind of the neat solution. This is, like I said, this is much easier to read, much more simple. But I think the first solution is necessary to understand first, just so you kind of understand what this solution even means. Okay, but yeah, I hope this helped, and I'll see you in the next one. Peace out.